So in the last lecture, I have given you one second test related to the chapter number 2, chapter number 3, and chapter number 4. So that second test was containing the 40 question. So the result of the same also I have displayed on our that result is also I have provided on your WhatsApp group. But within 10 to 15 minutes, because all the question were theoretical question, so within 10 to 15 minutes we will overlook that 40 question, and after that we'll start our section second. So rack test 2 on multi-pressure system refrigerant and PARS, that was the test. So first question is ODP was, the screen is visible to everyone, whether screen is visible, not yet, no? Okay, wait. Okay. Now whether screen is visible. Okay. So first question was ODP stand for. So we are knowing that ODP is nothing but ozone depletion potential. Answer D was the correct answer. Then second question was which of the following refrigerant are phased out due to monotrol protocol on ozone depletion potential. So phase out, that means which of the following refrigerant is phased out due to monotrol protocol. So R11, R12, and R21. So these are the three refrigerants which are got banned because of the same. So here these three refrigerants will be called as a phase out refrigerant. Whereas R32, we can use R32 as a refrigerant. So 1, 2, 3 was the correct answer. Then next question was TEWI. That TEWI will stand for total equivalent warming impact or total equivalent warming index. So that is nothing but answer B will be the correct answer. Total equivalent warming index, or that is also called as a total equivalent warming impact. So it is the combined result of ozone depletion potential as well as global warming potential. Then refrigerant should have high ODP, high GWP, low ODP, and low GWP. So correct answer is refrigerant should have low value of ODP as well as low value of global warming potential. So B as well as D was, sorry, C as well as D will be the correct answer. So next question, the chemical formula of R11. So R11, so as first word, first letter is nothing but 1. So 1 fluorine atom will be present. That's why CCl3F, that will be the correct value of or correct chemical formula for R11. Option A is the correct answer. Then next one, the chemical formula for R141 is, so you are knowing the nomenclature system. So by using that nomenclature system, you have to find out the chemical formula for R141. So out of that, 1 will indicate the number of fluorine atom. This 4 will indicate the number of hydrogen plus 1. So here as 4 atoms are present, so number of hydrogen atom will be 3. As 1 fluorine atom is present, so number of fluorine atom will be equal to 1. So you have to find out where 1 fluorine atom is present. So here 3 fluorine, 1 fluorine, 3 fluorine, 1 fluorine. So either B or C. But number of hydrogen atom is nothing but 4. Sorry, H plus 1 is nothing but 4. So number of hydrogen atom is nothing but 3. So here 3 hydrogen atoms are there. Here 2 hydrogen atoms are there. So option C will be the correct answer. So you can cross check by considering the number of carbon atom also. So number of carbon atom will be equal to 1 plus 1. That is nothing but 2. So C will be the correct answer. The next one, secondary refrigerants are also called as a brine solution, because cooler, wine, or synthetic solution is the wrong answer. Brine solution will be the correct answer. The next one, azeotrope mixtures are. So we are knowing that there are two series. First one will be called as a azeotrope mixture. Second one is will be called as a non-azeotropy. So azeotropy will consisting the 500 series. Non-azeotropy will consisting of the 400 series. So 500 series will be indicated by the azeotropy mixtures. So if non-azeotropy will be there, so that will be 400 series. The next one, inorganic compounds. So inorganic compounds means 700 plus molecular weight. So 700 series will be indicated by the inorganic compound. Then next question, the refrigerant gas used in calculation of ozone depletion potential is. So ODP is mainly caused because of the CFC type of refrigerant. CFC means chlorofluorocarbon type of refrigerant. So here, as fluorine atom is present in the CFC type of refrigerant, that's why the reference gas will be called as the R11 or R12, because that R11 will purchase the highest value of ODP. So CFC will be the correct answer. CFC. The next one, the reference gas used in calculation of GWP, global warming potential. That global warming potential will be mainly caused because of the carbon dioxide, and the reference gas in the GWP or calculation of GWP will be considered as a carbon dioxide. Then next one, R717 is a refrigerant name for. So what is the answer? 717, as this is the 700 series, that's why inorganic component. So 700 plus molecular weight. So 17 is the molecular weight for ammonia. That's why R717 will be the refrigerant called as the ammonia. C. The next one, for the refrigerant R134A, A stands for. So A is called will be A will be called as a isomer. Isomer means same chemical formula, but structure will be different. So that will be the isomer, not the isotope. So isomer will be the correct answer. The next, which of the following refrigerant is a blend? So blending. Blending means two or more than two refrigerants. When we are going to mix two or more than two refrigerant, then whatever resultant refrigerant we are going to form, that will be called as a blend of those two refrigerant. So here R134A, R22, those will be the halocarbon type of refrigerant. But if you see R410A, that as this is the 400 series, that means non-azeotropy refrigerant. Non-azeotropy means mixture of two or more than two refrigerant whose vapor and liquid phase remains identical over a long range of temperature. Whereas non-azeotropy means it is also mixture of two or more than two refrigerant, but there should not be the condition that those refrigerant will get well mixed. So R410 will be the correct answer. The next one, which of the following describes an azeotropy blend best? So azeotropy means mixture of two or more than two refrigerants which acts as a single refrigerant. So that is nothing but option A will be the correct answer. Then next one, multi-compression vapor refrigeration system used when. So when we are using the multi-compression refrigeration system, so when we have to decrease, that is required temperature lift, we have to decrease, then we have to use the multi-compression system. So required temperature lift decreases. That means whenever we are using the multi-compression system, required temperature lift. Temperature lift means suppose we want to achieve minus 150 or suppose minus 100 degrees centigrade from 20 degrees centigrade. So whatever the difference between minus 100 and 20 degrees centigrade, that difference is there, that will be called as the temperature lift, and that temperature lift will be decreased by using the multi-compression system. So B will be the correct answer. Then using intercooling in multi-stage compression system. So whenever we are going to do the intercooling, refrigerating effect can be increased, work of compression in higher stage of compressor can be reduced, maximum cycle temperature can be increased, and all of the above. So correct option will be, what will be the correct option? Whether with the help of intercooling we are using or we are able to increase the refrigeration effect? No. Whether we with the help of intercooling, whether we are able to increase or maximize cycle temperature? No. So option B will be the correct answer. Work of compression in higher stage compressor can be reduced because of doing the because of doing the intercooling. That means at the inlet of second compressor, we are providing the vapor which will be the nearly saturated vapor. So that's why work on a second compressor will goes on decreasing. Then next one, in multi-stage system, the refrigerant used should have the higher critical temperature and low freezing point. Then there is a possibility of migration of lubricant oil from one compressor to other. Operating pressure can be too high or too low, all of the above. So all of the above will be the correct answer. D will be the correct answer. Then, sorry. Then refrigeration system with liquid subcooler is used too. So why we are using the liquid subcooling? Because of doing the subcooling. Always we are doing the subcooling after condensation. After condensation or at the end of condenser, we are using the subcooling. So because of subcooling, we are ensuring that inlet of evaporator should be towards the maximum towards the liquid line. So here prevent the liquid entry into the compressor. So subcooling, whether subcooling will prevent the entry to the or liquid entry into the compressor, because subcooler we are always using after compressor, sorry, condensation. So after condensation there will be the expansion device, after that there will be the evaporator, but here they have directly mentioned that entry to the inlet of compressor. So there will not be any correlation with subcooling and liquid entry into the compressor. Prevent flashing of refrigerant liquid ahead of low stage expansion device. So flashing, what is the meaning of flashing? Flashing means formation of vapor from the liquid. So we are knowing that after expansion device, we are getting the liquid vapor mixture. Liquid vapor mixture. So we have to reduce the amount of vapor at the inlet of pump evaporator. We have to provide always the saturated liquid or the refrigerant which is having lowest value of the or lowest amount of the vapor in the liquid vapor mixture. So prevent flashing of refrigerant liquid ahead of low stage expansion device will be the correct answer. Reduce work of compressor. So subcooling and work of compressor, there will not be any type of correlation, because we are knowing that because of subcooling, or subcooling is also called as the undercooling. Because of undercooling, we are able to increase the refrigerating effect without affecting on the compressor work. So option B will be the correct answer. The next one, ammonia is one of the oldest refrigerant which is still used widely because it offers excellent performance. It is a natural refrigerant. It is inexpensive. All the three options are correct. That's why all of the above. Then CFC based refrigerants are being replaced as they are found to. So why we are using the CFC type of refrigerant? Because they are found to ozone depletion or cause ozone layer depletion. So as chlorofluorocarbon, that means as fluorine atom present in the CFC causes the ozone depletion. That's why those will be replaced by the another refrigerant or alternative refrigerant. So answer A will be the correct answer. Next one, which of the following refrigerant replaces R12 in a domestic refrigerator? So we are knowing that replacement for R12 is nothing but R134A. Replacement for R11 is nothing but R123A. So R134A will replace the R12 in domestic refrigerator. So we have seen in alternative refrigerant. Then ammonia refrigerating system. For ammonia refrigerating system, the tubes of shell and tube condenser are made up of. So we have seen the special feature of ammonia as a refrigerant. So whenever we have to use the ammonia as a refrigerant, we are not going to use copper or aluminum as a construction material, because that copper, aluminum, brass, that will be the corrosive in nature along with ammonia. So either we have to use the steel or cast iron. So here steel will be the correct answer. So steel. Then freon type of refrigerants are also called as a halocarbon type of refrigerant. So freon group of refrigerant will be called as a halocarbon. So answer A will be the correct answer. Then ODP value for R11. So R11 will be considered as a reference CMC for calculation of ODP, and highest value will be possessed by R11. That highest value is nothing but 1. Second highest value of ODP will be possessed by R12. That second highest value is nothing but 0.92. So R11 will possess the ODP value as a 1. Then in absorption refrigeration system, the compressor of vapor compression system is replaced by. So we are knowing that in case of FCRS system, in case of FARS system, compressor of FCRS system will be replaced by absorber, pump, generator, and pressure reducing valve. So answer will be all of above. All of above. Then next one, in which is the three fluid vapor absorption refrigeration system. So three fluid vapor absorption refrigeration system is also called as the Electrolux refrigeration system. Why we are calling it as a three fluid? Because it is consisting of the hydrogen, aqua, as well as ammonia. That's why we are calling it as a three fluid or Electrolux refrigeration system. Then next one, in the aqua ammonia vapor absorption system, which is used as an absorbent. So in case of aqua ammonia vapor absorption refrigeration system, we are using the aqua or water, that is also called as a water. Aqua as an absorbent, ammonia will be used as a refrigerant. Then next one, in the three fluid vapor absorption refrigeration system, hydrogen gas is used as a, so hydrogen gas we are using as a catalyst. Catalyst means to increase the rate of vaporization inside the evaporator. So how that hydrogen gas is increasing the rate of vaporization? By reducing the partial pressure of a refrigerant. Because if the pressure of the refrigerant in the condenser as well as in the evaporator will be same, then there will not be the easily evaporation of the refrigerant inside the evaporator. So to reduce the partial pressure, according to Dalton's law of partial pressure, by using the hydrogen gas, we are reducing the partial pressure of refrigerant inside the evaporator. Then next, in aqua ammonia and lithium bromide water absorption refrigeration system, LIBR water absorption refrigeration system, refrigerants are respectively. So in case of aqua ammonia, what we are using as a refrigerant? We are using ammonia as a refrigerant. Whereas in case of lithium bromide and water absorption refrigeration system, we are using water as a refrigerant. So ammonia and water will be the correct answer. Ammonia and water. So option C will be the correct answer. Then next question. Compared to compression system, absorption system offers the benefit of. So we have seen the difference between vapor compression and vapor absorption refrigeration system. So compared to compression system, absorption system offers the benefit of higher COP. Whether vapor absorption refrigeration system will have the higher COP? No, wrong answer. Lower refrigeration temperature. Whether we are able to decrease the temperature by using FCRS system? No, because with the help of FCRS system, we can achieve the lowest temperature as a -150 or less than -150 also. But vapor absorption refrigeration system will be used for achieving the temperature greater than 0 degree centigrade. That means mainly in case of air refrigeration system or air conditioning system, we are using the vapor absorption refrigeration system. Second is also wrong. Possibility of using low grade energy source. Yes, because in case of FCRS, we are using the mechanical work or electricity as a energy source. But in case of vapor absorption, we are using the exhaust gases or waste heat. So possibility of low grade energy is the correct answer. All of above? No, because first and second answer is the wrong. So C will be the correct answer. Then absorption of refrigerant by the absorbent in a vapor absorption refrigeration system. Absorption of refrigerant by the absorbent in a vapor absorption refrigeration system is accompanied by. या ठिकाणी काय विचारलंय? जे काय ऍब्झॉर्बर मध्ये आपण रेफ्रिजरंटचं ऍब्झॉर्प्शन करतोय कशाच्या साहाय्यानं जे की जे की विक एक्वा अमोनिया इन केस ऑफ एक्वा अमोनिया सिस्टीम विक एक्वा अमोनिया जे काही जनरेटर मधून बाहेर येतं आणि प्रेशर रिड्युसिंग व्हॉल्व्ह आपण ऍब्झॉर्बरला देत असतो ते जे काय रेफ्रिजरंट ऍब्झॉर्प्शन करतं ते कशाच्या बेसिसवरती करतं मेनली बिकॉज ऑफ रिलीज ऑफ हीट बिकॉज त्या ठिकाणी काय होत असतं आउटलेट ऑफ इव्हापरेटर वी विल हॅव द refrigerant vapor outlet of evaporator we will have the refrigerant vapor so that refrigerant vapor will get mixed or that refrigerant vapor will get converted into refrigerant liquid by absorbing that refrigerant by the absorbent. So that conversion of vapor into liquid will take place mainly because of a release of heat. So there will not be the absorption of heat. There will be the absorption of refrigerant, but there will be the release of heat. So option B will be the correct answer. Next question. Compared to the compression system, the performance of absorption system is very sensitive to evaporator temperature, is not sensitive to load variation, does not vary much on evaporator superheat, and last one is the all of the above. So if you see first option, compared to compression system, the performance of absorption system is very sensitive to evaporator temperature. So we are knowing that in case of vapor absorption refrigeration system, as the main refrigerating effect is produced mainly because of absorption. So there will not be the sensitivity of that vapor absorption refrigeration system depending upon the evaporator temperature. It is not sensitive to load variation. That is also wrong answer. Does depend very much on the sorry. The performance of absorption system is not sensitive to load variation. I think this is the correct answer, because if there will be the load variation, because we are knowing that vapor compression refrigeration system performance is poor in case of partial load condition, but vapor absorption refrigeration system is not poor for partial load condition because it is unchangeable. So option B will be the correct answer. Does depend very much on the evaporator superheat? No, because though there will, at the outlet of evaporator we are not getting the superheated vapor, then also it will not affect on the vapor absorption refrigeration system. So option B will be the correct answer. Option B will be the correct answer. 34. Compared to compression system, absorption system contain very few moving parts. It is correct one. Offers less noise and vibration, as less number of moving parts are there. That's why offering less noise and vibration. Correct one. Are compact for large capacities. All the three answers are correct. That's why all of the above will be the correct answer. Then next one, the ODP value for R134A is, as R134A, tetrafluoroethane. Tetrafluoroethane is the name of R134A. So that R134A is not containing or consisting any type of chlorine atom. So this is the HFC type of refrigerant, HFC, hydrofluorocarbon type of refrigerant. So as chlorine atom is absence, that's why it will not cause the ozone depletion. That's why we are replacing R12 by R134A. So here the ODP value for R134A will be equal to 0. A1 answer will be the correct answer. The next one, identify odd word. So R11, R12, R21 and R134A. So which is the odd word? Please give the reply. Which is the odd word? Write in the comment box. R11, 12, 21, R134A. Which is the odd word? Please write in the comment box. Remaining student. Only two students are active. Okay. So answer D is the correct one, because R11, R12, R21. So in all those three type of refrigerant, if you see, each and every refrigerant will consisting of the chlorine atom, but R134A will not consist of any of the chlorine atom. That's why R134A is the HFC type of refrigerant, whereas 11, 12, and 21. Those are the CFC type of refrigerant or HCFC type of refrigerant. But R134A will not consist of the chlorine atom. That's why R134A will be the odd one. Then next one, another odd word. So R500, 717, R118, 744. Which is the odd word? Please write in the comment box. Out of these 4 refrigerant, which one is the odd? R500, 717, 118, and 744. So option A will be the correct answer, because R500 means it is the azeotropy type of refrigerant. R717, that means ammonia, inorganic. R118, that R118 is also called as a R718. R118 is also called as a R718. It is the representation of water as a refrigerant. And R744, that is nothing but the carbon dioxide. So ammonia, water, and carbon dioxide belongs to the category of inorganic refrigerant, whereas R500 belongs to the category of azeotropy refrigerant. So R500 will be the odd one as compared to rest of 3 words. Then the refrigerant commonly used in vapor absorption refrigeration system is, which refrigerant we are using commonly? Write in the comment box. Commonly used refrigerant. Option is ammonia. Second option water. Third option hydrocarbon. Sorry, halocarbon. Next one is hydrocarbon, and last one is ammonia and water. What is the correct answer, remaining student? Any another answer from apart from option A? Any another answer? So if you see, simple aqua ammonia, practical aqua ammonia, as well as Electrolux refrigeration system, that system will consist of ammonia as a refrigerant, whereas in case of lithium bromide water vapor absorption refrigeration system, that system is consisting of water as a refrigerant and LiBr as a absorbent. So vapor absorption refrigeration system will consist of the refrigerant as a ammonia and water. So ammonia will be used as a refrigerant in case of simple aqua ammonia, practical aqua ammonia, Electrolux, that is also called as a 3-fluid. Whereas water will be used as a refrigerant in case of lithium bromide vapor absorption. So option E will be the correct answer. Option E will be the correct answer. When different temperatures are to be maintained at different point, then dash dash evaporator system may be used. So if I want to use the, or if I want to obtain different temperature at different location or different position, then I have to use the multiple evaporator system. So multiple will be the correct answer. Single, multiple, both, and none. So multiple will be the correct answer. Last question. In compound compression refrigeration system, compression of refrigerant is carried out in single compressor, multiple compressor, single as well as multiple, none of above compressor. So option will be B, that is nothing but multiple compressor. So this was related to our test number 2. So very few students got a satisfactory mark, but most of the students got below average mark. So you have to start, or you have to start your study. So that was related to test 1 as well as analysis of test 1 as well as analysis of test 2. So based on our section number 1, we have carried out two tests, test 1 as well as test 2. Result of both the tests I have provided you on your WhatsApp group. Now we are going to start our second section, that is related to the psychrometry. So our chapter number 5, that is from section 2, first chapter is related to the psychrometry. But before starting this chapter, one more important notice or important announcement. So related to the GATE exam. So yesterday only, yesterday that on the official website of GATE. So you might have read one notice. That means the registration date, last date of registration of GATE has extended. So if still you have not filled the GATE exam form, so today or tomorrow, in coming today or tomorrow only, you have to fill that GATE exam form. And after filling the GATE exam form, whatever PDF copy will be generated related to that GATE exam form, that PDF copy you have to provide, or you have to share that PDF copy to KR Sawan sir as well as your project guide. And it is compulsory for each and every student to fill the GATE form. So if you are not fill the GATE exam form, so today only or maximum up to tomorrow, you have to fill the GATE exam form. Don't wait for 7 of October to fill that GATE exam form. There may be the chances that website may get that speed of a website may get hang, or that speed may goes on slow, or that speed may goes on decreasing. So today or maximum up to tomorrow, you have to fill that GATE exam form. So related to psychrometry, if you see the syllabus, so as I have already told you, so from section number 1, chapter number 1 is the largest chapter. So once we have completed chapter number 1, then we are able to finish chapter remaining chapter 2, 3, 4 in very less time. Similarly, from the second section, chapter number 5 as well as chapter number 6, these two will be the biggest chapter. And once we have completed chapter 5, chapter 6, so remaining 2 chapter, we will be able to finish within short period of time. So university has allocated out of 20 hours, that means second section will consist of 20 hours, first section will consist of 20 hours. So out of 20 hours, university has given 7 hours for this chapter number 5. And syllabus for chapter number 5 will be moist air as a working substance, then psychrometric properties of air, use of psychrometric tables and charts. So here we have to use the psychrometric charts as well as steam table for solving of the problem. Then various psychrometric processes, its combination and calculation. Then ADP, that ADP is also called as the apparatus dew point temperature. Then coil condition line, sensible heat factor, bypass factor, air washer and its application. This will be the points which we have to cover under this chapter number 5. And if you see, there is a numerical treatment. That means this chapter will consist of theoretical part as well as derivational part to find out the formulas, and we have to solve the problems based on this psychrometry. So here on this chapter, there will be basically 2 types of problem. So first type of problem will be depend upon the derivations related to the psychrometric relation. Derivations related to the psychrometric relation. So those problem we have to solve by using the steam table. And second type of problem will be related to the, or will be based on the psychrometric chart. So here in this chapter, we have to study the psychrometric chart. So after studying the psychrometric chart, we have to solve the problems related to the different air conditioning processes. By using the psychrometric chart. Then assignment number 5. Up till now, we have completed 4 chapters, but not a single student have shown me a single assignment. So I have already told you you have to write down the assignment on the pages whatever are available with you. So you have to scan those pages and you have to send me those pages on my mail as an assignment. But not a single student has shown me single assignment. So start writing the assignment if you have not yet written those assignment. So assignment number 5. This question will be, you have to define the following term. First one is the DBT. DBT is called as the dry bulb temperature. WBT. WBT will be called as the wet bulb temperature. Specific humidity. And DPT. DPT will be called as the dew point temperature. Dew point temperature. Second question will be related to the problem based on steam table. So for a dry bulb temperature of 38 degrees centigrade and a relative humidity of 70%, calculate the following for air if barometric pressure or atmospheric pressure is 1 bar. So in that you have to find out specific humidity or value of specific humidity, value of enthalpy of air, then value of dew point temperature, and value of partial pressure of dry air. Then third question will be related to the short note on bypass factor of cooling coil. So there will be two terms, bypass factor of cooling coil as well as bypass factor of heating coil. And depending upon bypass factor of cooling coil as well as bypass factor of heating coil, you have to find out the efficiency of cooling coil as well as efficiency of heating coil. So this point will be related to the GATE. So as far as GATE exam is concerned, this chapter is also very much important. Then next question is again related to the problem. So on a particular day, the atmospheric air was found to have dry bulb temperature of 30 degrees centigrade and wet bulb temperature of 18 degrees centigrade. The barometric pressure was observed to be 756 mm of Hg. That means less than atmospheric pressure, because atmospheric pressure value is nothing but 760 mm of Hg. But here at atmospheric pressure or barometric pressure was observed as a 756 mm of Hg. So in that case, how to find out the relative humidity, specific humidity, dew point temperature, enthalpy of air per kg of dry air, that we are going to find out. Then next question is, a sample of moist air has dry bulb temperature 43 degrees centigrade, wet bulb temperature 29 degrees centigrade. So without making use of psychrometric chart, here you will clearly find that. Without making use of psychrometric chart, you have to find out partial pressure of water vapor, relative humidity, humidity of specific or humid specific heat, specific humidity, dew point temperature, enthalpy. So we have to derive the derivation to find out the equation for these many terms. Then next question is related to the problem based on psychrometric chart. So atmospheric air at 40 degrees centigrade dry bulb temperature and 18 degrees centigrade wet bulb temperature. This is not WEIGHT. This is WET. So by mistake, I have written WEIGHT. So 40 degrees centigrade DBT, 18 degrees centigrade WBT is flowing at the rate of 100 meter cube per minute through this space. And water at 18 degrees centigrade is injected into the airstream at the rate of 48 kg per hour. So here we have to determine the specific humidity and enthalpy of living air. Also, we have to determine the dry bulb temperature, wet bulb temperature, and relative humidity of the living air. So you might be knowing that whenever we are doing the air conditioning of any air for any of the plant, so there for conditioning of air we are using the air handling unit, that will be called as the AHU, air handling unit. So in that air handling unit, we are doing the various processes on the air. That means we are heating the air, cooling the air, we are adding the moisture particle, we are removing the moisture particle, or we are doing the combination of heating and humidification, cooling and dehumidification, or vice versa, depending upon our requirement. So here we have to find out the various properties of the air at the outlet of that AHU. Then next question, I think that will be the last question. Atmospheric air at 30 degrees centigrade dry bulb temperature and 75% relative humidity enters a cooling coil at the rate of 200 cmm. So meaning of cmm, cubic meter, cubic meter per minute. That is the meaning of cmm. 200 meter cube per minute or cubic meter per minute. That will be the meaning of cmm. The coil dew point temperature is 14 degrees centigrade and bypass factor of coil is 0.1. Find the temperature of air leaving the cooling coil, capacity of cooling coil in terms of TR. So whatever those problems are there, so if you are going to, or if you will be able to understand the basic concept, if you will be able to understand the basic psychrometric terms as well as basic psychrometric processes, then you will be able to solve the problem based on this chapter. But if you are not able to understand the basic psychrometric terms, basic psychrometric processes and psychrometric chart, understanding of psychrometric chart, then you will not be able to solve the problem by using you will not be able to solve the problem. So you have to understand psychrometric terms, psychrometric chart as well as psychrometric processes. So first point is about title of chapter. Decision. Okay. So here whatever psychrometry word is there, that is psychrometry is a Latin word. Whatever psychrometry word is there, that is the Latin word. So here if you are going to split that psychrometry word in the two words, first word will be the psychro and second word will be the metry. First word will be the psychro and second word will be the metry. So each and every word will consisting of some specific meaning. Out of that, psychro is, the meaning of psychro is nothing but moist air. Meaning of psychro is nothing but moist air. Moist air means, moist air is nothing but air which is consisting of the moisture particle. Air which is consisting of the moisture particle will be called as a moist air. Moisture particle means it is nothing but the water vapor present in a dry air. Water vapor present in a dry air, that will be called as a moist air. And whatever another word is there, metry. So metry is nothing but study of. So when you are going to combine both the words, so after combining both the word, whatever word will become, that will be called as a psychrometry. That will be called as a psychrometry. And meaning of psychrometry is nothing but study of moist air. Study of moist air. So whatever this chapter number 5 will be there, so that chapter number 5 will be completely related with the study of moist air. So there are various basic properties of the moist air as well as there are various basic processes which we can perform on the moist air. So all those things we have to study in this chapter. So you have to only keep in mind that chapter number 5 is related to the study of moist air. Now introduction. So as this is the, as we have started the section 2. So section was section 1 was related to the refrigerant or refrigeration, and section 2 is related to the air conditioning. So at the start of section 1 we have studied the definition of refrigeration. What is the meaning of refrigeration? So what was the meaning of refrigeration? रेफ्रिजरेशनची डेफिनेशन कोण सांगेल? What is the meaning of refrigeration? Will tell the definition of refrigeration. Anyone, please unmute yourself and tell the definition of refrigeration. So as we are knowing that refrigeration is nothing but a process of reducing and maintaining temperature. Process of reducing and maintaining the temperature below its surrounding or below its atmospheric temperature. That process will be called as a refrigeration. Similarly, we have to define the definition of air conditioning. So who will tell me what is the meaning of air conditioning, or what will be the definition of air conditioning? आपण एखाद्या रूमचं एअर कंडिशनिंग करतो किंवा एखाद्या प्लांटचं एअर कंडिशनिंग करतो म्हणजे नक्की आपण काय करत असतो? एखाद्या इंडस्ट्रियल प्लांटचं किंवा एखाद्या ऑफिसचं किंवा एखाद्या रूमचं तुम्ही एअर कंडिशनिंग करता, याचा अर्थ नक्की काय करता तुम्ही? काय करता नक्की? वळसंगे, अनम्यूट युअर सेल्फ.
Yes, sir.
काय करता? एअर कंडिशनिंग करता म्हणजे नक्की काय करता?
Maintain the temperature, humidity, and air pressure.
We are maintaining the temperature, humidity, and air pressure.
Yes.
So that will be called as the air conditioning.
Yes, sir.
Okay. Dada Gosavi, unmute yourself. Dada Gosavi. What's the meaning of air conditioning?
Constant temperature, maintaining temperature.
Okay. Atare. Gosavi, unmute yourself. Sorry, mute yourself. Atare. Srirang Atare. Swami.
Yes, sir.
What is the meaning of air conditioning? What is the definition of air conditioning? What exactly we are doing when we are doing the air conditioning of any of the room, any of the plant, or any of the industrial application?
Removal of moisture and heat.
Removal of moisture and heat. So whenever we are dealing with the word air conditioning, the general meaning of air conditioning means conditioning of air. So air conditioning is the branch of engineering science which deals with conditioning of air. Now, what is the exact meaning of conditioning of air? In this picture, you are observing that there is one living room, and in that living room, there is one split type of AC. And with the help of that split type of AC, we are maintaining the we are doing the air conditioning. We are doing the air conditioning means here. In this case, we are maintaining the desirable internal atmospheric condition, or we are maintaining the desirable internal atmospheric condition irrespective of external condition. बाहेरचं काही टेम्परेचर असू द्या, बाहेरचं काही ह्युमिडिटी असू द्या, बाहेरच्या टेम्परेचरशी किंवा बाहेरच्या वातावरणाशी आपल्याला काही देणं घेणं नाही. आपल्याला जे काही डिझायरेबल ॲटमॉस्फिअर किंवा डिझायरेबल कंडिशन आपल्याला अचीव करायच्या, त्या जर आपण डिझायरेबल कंडिशन अचीव केल्या इरिस्पेक्टिव्ह ऑफ एक्सटर्नल कंडिशन, so that process will be called as the air conditioning. So air conditioning is nothing but the process of supplying and maintaining desirable internal atmospheric condition irrespective of external condition. Supplying and maintaining desirable internal atmospheric condition irrespective of external condition, that will be called as the air conditioning. So if you are having pen and notebook, so write down the definition of air conditioning. All of you, please write down the definition of air conditioning. Please write down the definition of air conditioning. So air conditioning is the branch of engineering science. Air conditioning is the branch of engineering science which deals with conditioning of air, which deals with conditioning of air. The meaning of conditioning of air means supplying and maintaining desirable internal atmospheric condition irrespective of external condition. Engineering science which deals with conditioning of air, full stop. Next line, that is next line, air conditioning is the process, that is air conditioning is the process of supplying and maintaining, air conditioning is the process of supplying and maintaining desirable internal atmospheric condition, supplying and maintaining, or process of supplying and maintaining desirable internal atmospheric condition irrespective of external condition, irrespective of external condition. So that will be called as the air conditioning. Now whenever we are doing the air conditioning, so that air conditioning can be done for two purposes. There will be basically two purposes of that doing the air conditioning. So first purpose may be for human comfort, or second purpose may be for industrial processes or for industrial application. So for any of the purpose, that means whether you are doing the air conditioning for human comfort or whether you are doing the air conditioning for any of the industrial purposes or any of the air industrial application, there you need to control four parameters or four factors. So what are those four factors which you have to control simultaneously while doing the air conditioning? Out of those four factors, first factor is nothing but the temperature. What exactly you are doing, that means conditioning of air, that means what exactly you are doing, you are maintaining the temperature, you are maintaining the humidity, you are maintaining the purity of air, purification of the air, and you are maintaining the air velocity. So until and unless you are not going to maintain all the four parameter, you are not going to maintain all the four parameter, you are not going to achieve, or you are not going to achieve the desirable internal atmospheric condition. That's why in another word, air conditioning can also be defined as, air conditioning can also be defined as, it is a simultaneous control of, it is a simultaneous control of temperature, humidity, then air purification or air purity, and air velocity to obtain desirable internal atmospheric condition irrespective of external condition. If you are going to fail to maintain any of the parameter, म्हणजे तुम्ही काय केलं, एअर कंडिशनिंग करत असताना तुम्हाला जे काय डिझायरेबल टेम्परेचर पाहिजे होतं ते तुम्ही काय केलं, अचीव केलं. जे काय तुम्हाला डिझायरेबल ह्युमिडिटी पाहिजे होती तेवढी तुम्ही काय केली, मेंटेन केली. जे काय तुम्हाला डिझायरेबल एअर व्हेलॉसिटी पाहिजे होती तेवढी तुम्ही मेंटेन केली. बट इफ यू आर गोइंग टू फेल टू मेंटेन द एअर प्युरिफिकेशन, if you are going to maintain the air purification, that means whatever conditioning air you are providing for living room or for any of the industrial application, if that conditioning air is consisting of the any of the another contaminant, or that order of that air is very rush, or that order is not desirable, then you are not doing the air conditioning. Or if you are going to maintain three parameters, suppose temperature, humidity, and you are maintaining the purification of air, but whatever air you are supplying, that air supply of air is not consisting, or that supply of air is not having the proper velocity, either that speed of that air is very fast or very slow, then also you are not going to achieve the desirable internal atmospheric condition. So whenever you have to do the air conditioning, you have to do the simultaneous control of temperature, humidity, air purification, as well as air velocity. So that will be the another definition of air conditioning. Now next point is related to the psychrometric terms. Next point is related to the psychrometric terms. So we have to see the various definitions. We have to see near about 11 to 12 definitions we have to see under this psychrometric terms. Now what is the time? 2:28. So time is almost over. So whatever the next point psychrometric terms is there, that psychrometric terms we are going to see in the next lecture. In that psychrometric terms we are going to see what is meant by dry air, what is meant by moist air or definition of moist air, then what is meant by saturated air, then we are going to see what is meant by dry bulb temperature, what is meant by wet bulb temperature, then what is meant by wet bulb depression, what is meant by dew point temperature, then dew point depression. Then we are going to see the definition of humidity or specific humidity, that is also called as the humidity ratio. Then we have to see the degree of saturation or percentage humidity, and last one we have to see the relative humidity. So these many definitions we have to see under the term called as the psychrometric terms. So those psychrometric terms we are going to see in the next lecture. So now you have to write down your roll number in the chat box. Once again I am appealing you, fill the gate forms. If you have filled the gate forms, submit those gate forms to the Fiat Sawan sir as well as your respective guides. So don't wait for 7th of October or don't wait for last date for filling of the gate form. Fill that gate form either today or up to tomorrow only. So if you have written the roll number, you can exit the lecture and you can join the another lecture. Thank you. Yeah.
हॅलो सर. हॅलो.
हा बोला.
हॅलो सर, रोल नंबर टाईप होत नाहीये माझ्याकडून, म्हणजे सेंड होत नाहीये इकडून.
कसं काय सांगा, रोल नंबर सांगा.
तुम्हाला B30 30 हो.
ओके सर.
थँक्यू सर.